Hey y'all, welcome to the very first video lecture of Intro Psychology this semester. Right now at this moment, if you have not yet watched the tutorial video, please go to Canvas and watch it right now. It will actually help you fill out this worksheet with the least amount of work possible. I do not want you to copy the PowerPoint slides. Those are available on Canvas for you to have at your will. But I also don't want you writing sentences upon paragraphs on this worksheet. That is so not necessary and is a total waste of your time. So please go watch the tutorial video before you start working on this, because it will make your life a whole lot easier. So go watch that if you haven't yet. If you have, then we're ready to get started. Okay, so the very first thing that we talk about in Intro Psych is Wilhelm Wundt, and he was a psychologist from Germany, and there's exactly two things that you need to know about him. Number one, you need to know that he was called the father of psychology, and the reason for that is because, this is the second thing you need to know, that he developed the very first psychological laboratory in all of psychological science. And then the book will go into kind of some specifics about the two first schools of psychology, structuralism and functionalism. One good thing about psychology is a lot of the names that we choose for things also describe what they believe or their purpose. And so structuralism focused on the structure of the mind, whereas functionalism focused on the function of the mind. But one thing that you definitely need to know is that introspection was a key practice of the school of structuralism, not functionalism. Introspection goes with structuralism. And introspection was really just this idea that a structuralist psychologist would ask you to describe your sensations doing any given thing. So they might have you close your eyes and smell a rose and describe how the smelling process feels to you or what thoughts it evokes in your mind. Or they would have you sit down and watch a sunset and try to describe your innermost experiences. That was the practice of introspection used in structuralism. Also, associate functionalism with this idea of adapting to your environment. That's often how we talk about it in test questions. The issue with introspection is that it's unreliable, subjective, immeasurable, inconsistent, and relies on your subject's ability to truthfully and correctly describe their experiences without being able to verify it. So really what that comes down to is, one person's experience of smelling a rose could be entirely different than another person's experience. That's what makes it unreliable, inconsistent. It's subjective, so it's dependent entirely upon your specific experiences, not the general experiences of others. You can't measure people's thoughts or experiences, and you're relying on the person who's reporting their thoughts and feelings to be able to do so both truthfully and accurately. So introspection it wasn't scientifically valid, which is why it failed. All right. So when it comes to these contemporary psychological approaches, I promise you'll have test questions they'll just give you some kind of description, which, psychological approach emphasizes this idea or practices this thing. So all I really want you to write down right now next to all of these little approaches are a couple of keywords that you should be looking for. So next to cognitive psychology, write down mental processes / thoughts. Mental processes / thoughts. Anytime we're talking about cognitive psychology, we're talking about the inner workings of your brain, your thoughts, your feelings, the way your brain functions for memory, for things like this. Mental processes and thoughts. Cognitive neuroscience, we're going to be talking about specifically brain activity. You will see that word come up over and over in test questions if we're talking about cognitive neuroscience. So anytime you see brain activity, think neuroscience, brain activity. And then cognition is the first part of that, just like in cognitive psychology, thoughts, mental processes. Evolutionary psychology, look for the word evolution. That tends to be in the stem for a lot of these questions. And then also things like natural selection or anything sort of mentioning a Darwin type of principle is going to be something that will likely fall under evolutionary psychology. Also words like adapting, are important. But yeah, evolution, natural selection are the two most common. So write those two down next to evolutionary psychology. And then with behavior genetics, we're looking at the contributions of genes and also the environment. So genes plus environment, or as you'll hear it called through the rest of the semester, the nature versus nurture debate. That's exactly what behavior genetics is focusing on. So genes slash environment, also nature slash nurture. Write those two concepts down. Psychodynamic is also sometimes called Freudian. You might want to write that down. Psychodynamic is also called Freudian psychology. And your keywords for psychodynamic are unconscious or childhood experiences. Psychodynamic theory is all about going back to the childhood roots and seeing what old traumas you have left in your unconscious mind that are, causing you to behave some kind of way presently. And then under behavioral, the key word is observable. Behavioral psychologists basically said, hey, we can't do things like introspection. We really can't figure out what's going on inside the brain. Thoughts are just too foreign, essentially. We'll never be able to think what people are thinking. We'll never be able to tell. And so all we're going to focus on in the behavioral approach is people's observable responses, what we can actually witness people doing. Their behavior is the only thing that we can study. So observable is your keyword for that. And then with social cultural, really you're just the prompt will say something about, how psychology applies over various situations or cultures. So those are really your keywords, situations or cultures. It's not mentioned here in the book, but there are a lot of questions that will also ask about humanistic and positive psychology. So when we get to those a little bit later, I'll give you some keywords for those too. Okay. So the difference between basic and applied research is that basic research is conducted just to gather information. I only do this research because I just want to know something. Whereas applied research is research that you're undertaking for the purpose of solving a problem, for the purpose of applying the knowledge that you gain towards solving a problem. So basic research is essentially just observing something and collecting information just to know about it. But applied research is I'm conducting this research for the purpose of doing something. So like cancer research, for example, would be obviously applied because no one's trying to research cancer just to know more about it. Everyone's trying to research cancer because they're trying to cure it, because it's an identifiable problem. So you kind of have to extrapolate that a little bit and think about what the question might be asking you, if it sort of forces the concept to be applied in order for it to be ethical or not. All right. And then these 4 types of practices. Now these you're going to be asked test questions about because how many multiple choice answers do we normally have? 4, A, B, C, and D. So one of these branches will be each of your answer choices. So what you want to know to tell the difference is this. Counseling psychology is just for day-to-day problems. So counseling psychology is not for mental health, not for psychological disorders. Counseling psychology is problems that everybody has, not just disordered people. So counseling psychology is going to help you if you're having trouble adjusting to your new school, there's tension in your family, you want to see a marriage counselor, stuff like that. Whereas clinical psychology and psychiatry deal with psychological disorders, mental health. Now the difference between those two, clinical psych and psychiatry, is clinical psychologists do not use medication, they cannot prescribe medication, whereas psychiatrists can prescribe medication. And psychiatrists are the only type of psychologist that is able to prescribe medication because they have a medical degree. They are the only branch that has a medical degree. So counseling psychology, not for psychological disorders. Clinical psychology and psychiatry are for psychological disorders, but clinical psychology does not use medication. Psychiatry does use medication. And then really the distinguishing difference between community psychology and everything else is that community psychologists work within groups, not individuals, whereas all the other 3, counseling, clinical, and psychiatry, all work with the individual person, whereas community psychologists try to figure out how to implement policies that affect big groups of people or institutions of people. And community psychologists also do not deal with psychological disorders. Okay. So hindsight bias is really only used in the context of saying that once someone finds out the result of something and then they say, oh, well, I would have known that, I could have predicted that, that is hindsight bias. When you are presented with the answer and so you rationalize that answer and think, oh, well, I would have known that, that's so obvious. So once we are given the answer, the outcome of something, we have a tendency to believe that we knew the answer or could have predicted the outcome all along. Hindsight bias is also called the I knew it all along phenomenon. Overconfidence is really just this idea that once we commit to something, we really hold our thoughts and beliefs in high regard. Even when they're incorrect, we tend to be overly confident about those beliefs, especially ones that really matter to us or have some kind of sentimental or emotional value or moral value too. But humans tend to be more confident than they really are correct. And then perceiving order in random events is sort of things like when we see shapes in clouds or a man on the moon, we sort of make sense out of nonsense. And this is really just in an effort for humans to understand and make sense of the world that we're in. We just try to make sense of things by turning them into concepts that we are familiar with or putting them in likeness with those. Okay, and that's everything basically in the prologue, so moving on to chapter 1. Okay. So really, the difference between a theory and a hypothesis is a theory is something that should not be used casually. Oftentimes in just sort of like conversation, we might say, oh, I have a theory about something, and we don't really mean it all that seriously. So when we talk about it in science and in psychology, a theory is something that has been well developed by multiple studies that have all sort of confirmed or at least supported a general idea, an overarching concept, a theory. But a theory has to be well supported by observations and research. Whereas a hypothesis is just a prediction that we're using when we go to conduct an experiment. So theories are made up of hundreds of hypotheses that were either confirmed or rejected based on the outcomes of the studies. So a hypothesis is sort of your best guess, and then a theory is a well-developed idea based on research. All right, operational definitions. You want to write down the word replication next to operational definitions. Write down the word replication, replication. I want you to write that down, replication. And replication is the purpose of having an operational definition. So what an operational definition is a very carefully worded definition that we're going to use to measure something in some kind of research study. And the reason that we've got to be so careful with the way that we word them is because we want to be able to word them so carefully that any competent person could come along, use our definition, and conduct the study in the exact same way that we did. And that's replicating the study, conducting the study again in the exact same way that the initial researcher conducted it. And so if you're trying to measure aggression, you can't just say, any type of confrontational behavior is aggression. Well, to what degree is something confrontational? If someone, punches a wall, that's not exactly confrontational to another human being, but it could still be considered an aggressive action. And so you have to be very careful with the way that you word what you're measuring and the way that you maybe put it on a scale or something like that, so that any competent researcher could come along after you and replicate the study in the exact same way that you did it and get, hopefully, the same data. And that's the reason that replication is important to scientific experiments, is because if studies are replicated over and over and the results of the studies are the same over and over, then it starts to build support for the hypothesis and ultimately the theory. So the more replication we have, the more certain we can be in the outcome if the outcome has been consistent from study to study. There are 3 types of descriptive research methods, and then we've got correlational and experimental research methods. So sometimes a test question will ask you, which of the following is not a descriptive research method, right? And people tend to think that correlation and experimentation are ones that fall into descriptive just because they were also mentioned in the chapter. So understand that correlation and experimentation are their own things, and the 3 descriptive research methods that we have are case studies, naturalistic observation, and surveys. So when they say which one is not, they could say case study, naturalistic observation, survey, and correlation. And correlation would be the one that is not a descriptive research method. Correlation is its own research method. Experimentation is its own research method. Okay, so a case study is an in-depth study that you do on one individual or a very small group of people, and you're trying to find out information that you can apply to the general population. Generally, case studies are used when it's not exactly ethical to do something to someone, but it's already happened to them. So, for example, we'll talk about Phineas Gage, who worked on constructing the railroads, and he actually had a metal rod go all the way up through his skull, and he lived after it happened. So we did a case study on Phineas Gage to see what parts of his brain were damaged and how that affected his behavior. But obviously, we can't bring in a random sample of human beings and force them all to take iron rods up their skull in order to study what happens to them. So when it's unethical to do it to other people, we can do a case study on someone who already suffers from it or something like that. One pro of a case study is that you can focus deeply on the subject or small group of subjects involved, and so you can really get down to the nitty-gritty details of their specific disorder. You have a lot of time to spend with each participant. But the con is that usually the subjects are in uncommon circumstances. How many people really get a metal rod up through their skull? And so the sample size really can't be very large, and the principles researched are sometimes hard to apply on a wider scale. Just because one person experienced something doesn't necessarily mean that that's the general rule for everybody else. They could be the exception, but we don't know because we don't have enough other people to compare them to. Naturalistic observation is really just what it sounds like. You are observing people in their most natural circumstances. So the biggest part of naturalistic observation is that you are not manipulating anything. There is no controlled laboratory setting. You are just sitting out, in the public park or whatever and watching people do what they do and taking notes on it, observing it. But you cannot interfere with what anyone is doing. So the pro of this is that when people don't think they're being observed, if you haven't told them that they're in a study, they're going to likely act naturally, which will help the experimenter to get a good idea of how people honestly act rather than how they act when they know that they're in a study and they might be being looked at for certain behavior. So the pro is that people generally act pretty naturally. And the con is that there's no manipulation that you can do to the situation. You can't control the circumstances of the study. And so there's only so much information you can really extrapolate from naturalistic observation. You can't really do any specific circumstance type stuff. And then surveys, I'm sure you've all filled those out. They're just self-reported data from people who are willing to answer a questionnaire, essentially. And so the pro of a survey is it's really easy to get people to fill them out. So you can get a pretty large and representative sample of people who are willing to participate by just doing your survey. But the con is that we really have no way of verifying whether or not people are telling the truth when they answer a survey. And so the data could be unreliable because they're just not being honest. Okay. Difference between a population and a sample is the population is the entire group of people that you're trying to generalize a result to. So if you're trying to figure out, if something is common to all women, then your population is all women in the whole world, right? But your random sample is just a subset of the population, which should be representative of the population. So if your population is all women, but your random sample just includes women at Baylor University, you've really sort of misrepresented what you're doing. Because if the population is all women, then we're talking all women from every country, all women of every culture, of every ethnicity, of every race, of every, sexual orientation or gender identity. We're talking all women here. But you've only surveyed women at Baylor University, which is not representative of all of the different variations of types of women that we could have. So instead you would say, well, okay, then my population is all Baylor women. And then my random sample, which is made up entirely of a large number of Baylor women, is more representative of the population in the whole. When it comes to a random sample, what you really need to know and what you should write down next to this is that if a sample is truly random, that means that every single person in the entire population had an equal chance of being selected to participate in the study. It is only a random sample if every member of the population had an equal chance of being selected to participate. So if we were again talking about the issue of saying, my population is all women, but my random sample is just some Baylor women. Well, all the other women of the world did not have an equal chance of being selected to participate in this study. You only chose to go after Baylor women because that was accessible to you. So it's not truly a random sample because not every member of the whole population of women across the world was eligible to be selected or had an equal chance of being selected. And then the purpose of random sampling, there are two. The first is to get a representative sample, which is what we've been talking about. The second is to lower or control for bias. So again, the purpose of random sampling, write this down, the purposes of random sampling are, number one, to get a representative sample, and number two, to lower or to control for bias among people or among the sample. Okay, correlation. So there are two things that a correlation coefficient tells you. And the first of those is the strength of a relationship. The second is the direction of the relationship. And what we can do with correlations is we can make predictions. We can predict that as one thing rises, another thing will rise with it, or as one thing rises, another will fall against it, that sort of a thing. Correlation is not causation. You'll hear that over and over and over and over and over again in your scientific education. Correlation is not causation. So I will give you my favorite example of this. Let's say that here we're plotting drowning deaths. And here we're plotting ice cream sales. As it turns out, drowning deaths increase as ice cream sales increase. Crazy. Is that because buying ice cream causes people to drown? Certainly not. Is that because drowning causes people to purchase ice cream? Also, definitely not the case, right? So what you need to understand is there's a possibility that there's a third variable at play here. For example, season or temperature. As we go into the summer season and the temperatures rise, people go swimming more often, so they drown more frequently, but they also buy ice cream more often because it's warm. So it's things like this, like the third variable, the confounding variable is what we'll call it, are having an effect on the data. And so we can't say that ice cream sales and drowning have a causal relationship. One does not cause the other, right? So correlation is not causation. We can never interpret it as causation, even if it logically makes sense that one thing might cause the other. You still can't, from a correlational study, figure that out. So we cannot use correlation to prove that one variable causes another. The best we can do with correlation is make predictions. So with this, we could make the prediction that, when we start to see an increase in ice cream sales, we'll also start to see an increase in drowning deaths. But it will be because of the underlying factor that the season has changed and the temperature is warming up. and then a correlation coefficient. Now this is something you'll be asked a test question on for sure. So the correlation coefficient tells you two pieces of information, as I mentioned before, the strength and the direction of a relationship. The correlation coefficient ranges between a value of -1 and +1. Values like positive 2.4 or positive 8.6 don't exist. There is nothing greater than +1. There's nothing less than -1. So you can't have -3.2 or -10.6. You can't even have -1.01. Anything further negative than 1.00 is not an option. And then right in the middle, we have a 0 correlation. So here's the thing that you need to understand is the weakest correlation that you have is at 0. Whereas +1 and -1 are the strongest correlations you can possibly get. So positivity and negativity has no effect on the strength of the relationship. So over here, a -1 correlation is a perfect downward relationship, whereas a +1 correlation is a perfect upward relationship. So the sign, positive or negative, tells you the information of the direction of the relationship. Does it go up or does it go down? If it goes up, it's positive. If it goes down, it's negative. Whereas the strength of the relationship is told to you by the distance that the value exists from 0. So, for example, a 0.2 correlation is weaker than a -0.8 correlation because 0.8 is farther away from 0 than 0.2. Never mind the plus or minus, it's just about distance from 0. And a scatter plot is just one of those plots that you see with a bunch of different dots, and then normally there's like a line of best fit somewhere in there. That would be a scatter plot. And scatter plots communicate strength of the relationship. Also, you can kind of see the direction usually, but sometimes you fall into seeing an illusory correlation when there is no statistically valid relationship that exists, but you sort of perceive there to be one. So, you know, with sort of a sparse enough cluster of dots, you could sort of see that maybe they were trending upward, but maybe you could also sort of see that they were trending downward, and really it's pretty close to a flat line in reality. So an illusory correlation is the illusion of a correlation. And usually we see those because we expect to see some kind of pattern in the data, so we kind of tell our brains to see one even if there isn't one truly there. So in order to be sure that you're not seeing an illusory correlation, you would want to calculate the line of best fit and figure out exactly what the correlation coefficient of any given scatter plot is. And then regression towards the mean is a concept that will come up again when we get to intelligence. But regression towards the mean is really just this idea that if you had some kind of extreme score, whether it was really high or really low, the next time that you are retested, you're likely to fall closer to the average. So if on your first exam you see that you get a 96, don't get lazy, because next time you're more likely to fall back towards, fall back towards the mean, the average of the class, which might be something closer to an 80 or 75, right? But also, if you happen to get like a 20 on the first exam, don't worry, because you'll probably do better on the next one. You're likely, when retested, to score closer to the average if you had an exceptionally high or exceptionally low score. And to regress is to fall back towards something. So you fall back towards the mean. You get pulled back towards the mean. Whether you are on the high end or the low end, you regress back to the standard. Return back towards the mean. All right. So when it comes to experimentation, the fundamental difference between correlation and experimentation is that correlation will help you predict things, but experimentation can tell you cause and effect. correlation is only good for prediction. Experimentation can confirm cause and effect. It can confirm and clarify cause and effect. Whereas correlation is never causation, right? Correlation is prediction. Experimentation is causation. So I'm not going to spend too much time on this because I'm assuming that in all of your other scientific education in high school, you learned about independent variables, dependent variables, and confounding. But the independent is the variable that you change. The dependent is the variable that you're recording, the one that responds. And a confounding variable is something that is unintentionally affecting the data. So you want to not have confounding variables if you can help it. But just like how I talked about ice cream sales and drowning deaths going up together, the third variable, the confounding variable, would be that temperature was affecting both of these pieces of data to make them look like they were happening maybe because of one another or happening together. So an experimental group is the one that receives the independent variable, receives the treatment. So if your study is on, a medication, whether or not it works, then you would use a real medication and you would use a placebo. And your experimental group gets the real thing, whereas your control group gets the fake thing, or what we call the placebo. And they are just exposed to everything completely the same as the experimental group, except the one independent variable that you are studying. So all of the conditions in which they live or are subjected to in the study are exactly the same as the experimental group. The only difference in the way that they are treated, the only difference in their whole experience, is that the experimental group is given the real drug, whereas the control group is given a placebo or a fake substitute. And then random assignment. So you definitely want to notate stuff about both random sampling and random assignment. So when it comes to random assignment, it's when you already have your random sample of people, but now you have to assign them to either the experimental group or the control group. So know that random assignment is only used in experimentation, not in descriptive research methods or correlational research methods, just experimentation. And so once you have your random sample, you have to figure out, well, who is going to go in the experimental group, who is going to go in the control group. And the key to random assignment is much like random selection. And it's just this idea that all members of the sample have to have an equal chance of being placed in either the experimental or the control group. So for random sampling, every member of the population has to have an equal chance of being included in the sample. For random assignment, every member of the random sample of the selected participants has to have an equal chance of being placed in either the experimental or the control group. And now the purpose of random assignment, and you should write this down, the two purposes of random assignment are, number one, to minimize differences between groups. Minimize differences between groups. And so what that means is, if I'm doing a study on a drug and I have my experimental group and my control group, I don't want to put all of the men in the experimental group and all of the women in the control group, because maybe there's a fundamental difference between men and women. And so by putting the men in the experimental group and only reporting their experiences, we could be leaving out important information on how the drug might affect a woman or something of that nature. And so we randomly assign to try to minimize these differences between groups, to try to just evenly spread out people in such a way that we don't have a group of people with all one thing in common that are stuck in one group together versus another group of people who all don't have that in common, for example. So purpose of random assignment, two purposes. First one is to minimize differences between groups. That will be a test question answer. And the second purpose of random assignment is to eliminate confounding variables. And this really goes along with the first point, but to eliminate confounding variables. The double-blind procedure is fairly appropriately named because it is double-blind. So both the participant and the researcher are blind to whether or not the participant is actually receiving the true treatment or if they are receiving a placebo. So let's take, for example, a study on headache medication, right? So we've got an experimental group which receives the real headache medication that we're trialing, and then we have a control group who we're going to give a placebo pill to and tell them, this is a trial headache medication, let us know how it works. But neither the person participating in the procedure or the researcher who's recording the data knows whether or not that person is truly getting the medication or the placebo pill. There's a third party that tracks that record. And so this helps to control for two different things. On the side of the participants, it helps to control for placebo effect. And placebo effect is really just this idea of mind over matter. If you give someone a pill that has nothing in it, besides maybe just a sugary powder or something like that, something that should not actually affect headaches, and you tell them, hey, this is a headache medication, let us know if it makes you feel better, and they come back and they say, wow, this has taken away all of my headaches, this is fantastic, then we know that it's not because the medication actually did anything, because it wasn't medication, but it's because the person believed that it would, that they saw improvement in their symptoms. So it's this mind over matter, oh, I'm taking a pill, so it must help me. It must help my symptoms of a headache. So the double-blind procedure helps with placebo effect because we can identify later whether or not they actually got the treatment medication or if they only saw improvement because they believed that they would. And then on the other end of it, it also helps to reduce experimenter or researcher bias because the researchers now don't know whether or not to expect to see improvement in symptoms because they don't know whether that particular participant actually got the treatment medication or got a placebo pill. Okay, and you can read through this. It's just about well-being of animals. But the two things you really want to know about are informed consent and debriefing. And so when it comes to informed consent, basically you have to tell your participants anything about a study that could make them to an important degree uncomfortable. So if you're doing something like drawing blood from your participants, you have to disclose that because that is something that could make people fearful or uncomfortable. However, you don't have to disclose everything because there's some element of psych research where it just wouldn't be helpful if the people knew what you were looking for, right? If you're trying to track deception, for example, you don't want to tell them, hey, I'm going to be measuring for signs that you're lying to me because that might affect the way that they behave. And so to some degree, it is okay to withhold information, but what you have to do in that case is debrief at the end. And debriefing is just after you're done telling them what you really did, what the true purpose was, what you were actually looking for, and you have to tell them about anything that you deceived them on. So when you're debriefing, you're kind of lifting the veil and saying, hey, this is what really happened. I'm telling you the truth now. So when it comes to informed consent, they just need to have enough knowledge to be able to adequately justify whether or not being in the study would make an average person uncomfortable, and therefore they need to have enough information to determine whether or not they want to consent to such uncomfortability or potential uncomfortability. And then debriefing is just telling the truth at the end. 4 components of ethics codes are that you have to get that informed consent, you have to protect participants from harm or discomfort, you have to keep things confidential, and then you have to debrief at the end. So those 2 concepts of informed consent and debriefing are very important. You have broken the ethics code if you do not do either of those things in a study. And then lastly, we've got mean, median, and mode. These are just your measures of central tendency. So when it comes to the mode, that is the most frequent score that you have. So if you're taking a survey on how many kids people have, 2, 3, 4, 5, 6 or above, 1, 0. Let's say most people have got 2 or 3 kids. A couple have got just 1, few have 0, right? A couple have above 6, 4, 5, right? So your mode is the value that has the most data or the most frequently occurring score. That is your mode, the one that you have the most of. The mean would be calculated by taking all of these values, adding them up together, and then dividing them by the total number of x's that we have. So the mean is just the average. You're just calculating the average. And then the median is the middle score. So the way you would go about that is cross out your highest and your lowest score and keep going. Next highest, next lowest, next highest, next lowest, next highest, next lowest, so on and so forth. Next highest, next lowest. Oh, and there we are. Our median score is going to be a 2 then. Know that the range is just the highest score minus the lowest score. And then standard deviation always goes with the mean. If you have computed the mean to be your best representative of your data, then you're going to report the standard deviation along with it. And really what that means is you're going to see a bell curve a lot in psych science. And some bell curves are really fat, some bell curves are really skinny. And so let's say that this is, some kind of test score. So 0 to 100, 0 to 100. So this shows that, there was quite a number of students who maybe scored between 20 and 80, right? And quite a few students who scored between 40 and 60. There's a lot of variation here. These arrows are very wide. That's a lot of variation. So that's a big standard deviation because the arrows here are wider. The curve is fatter. So it's a big standard deviation. Whereas here, well, it looks like most students actually scored in a much thinner range of maybe, 40 to 60 here. But up here, a lot of students still scored between 50, well, more like 45 and 55, right? And so this is a small standard deviation because the width of the curve is tiny, tiny. So standard deviation really measures the spread of the data. And then the normal curve is what I just talked about. It's just this like perfectly shaped bell curve that represents almost every natural phenomena in all of science. It's crazy, everything that it can determine or model. And then lastly is this idea of statistical significance. Statistical significance, I'm gonna write some stuff here, is reported with an alpha value. And the standard alpha value is 0.05. Sometimes you'll see 0.01, 0.001 is one that's like really good to have, but the standard for this data is pretty reliable, essentially, is for your alpha value to be at 0.05. And what that stands for is 5%. 5% of what? 5% chance that you got this result by accident. 5% chance that the result that you got occurred by chance. So the lower that your alpha value, so if we have a 0.01, now we only have a 1% chance that something's wrong with your study. Over here, we have a 0.1% chance that something's wrong with your study. So the lower the alpha value, the greater the statistical significance. The lower the alpha value, the greater the statistical significance. If the alpha value is low, then we know that the data didn't happen by chance, or most likely didn't happen by chance. And so that means that our data is statistically significant. It's relevant. It's telling something truthful or important, right? So the lower the alpha value, the greater the statistical significance, and vice versa. The higher the alpha value, if we had a 0.25 alpha value, well, now there's a 25% chance that something's wrong with our study, and we don't want that. That makes our data unsignificant or insignificant. So the higher the alpha value, the lower the statistical significance as well. Okay, that was a long one. Thanks for staying tuned, and I will see you in the Zoom session. Be sure to turn in your pre-session worksheet with all those things that I specifically told you to write down should be written down on there. So things like those key words back up in the cognitive psychology, cognitive neuroscience, etc. You should have a certain word written down next to operational definitions. You should have things written down for random sampling, random assignment. Those are all things that I should expect to see on there. Okay, I'll see you at the Zoom session.